All right. So today we are dealing with reaction types. So let's discuss those real quick. Let's make sure we know the current week schedule still. So that's a key thing. So if we take a look, discuss any questions on naming and balancing. I'm going to go over that again real quick. Naming and the naming and balancing. Today I'm going to discuss reaction types, and then you can break off and do the reaction types lesson. And there's a video here that goes through it, and a video that I made as well. So let's start on that with the visualizer. So yesterday we talked about balancing reactions, making sure that they have the same number and same types of atoms on both sides. So we'll go over that a little bit, but today's major lesson is to talk about reaction types. So when you're looking at a reaction, there are 5 different reaction types. There's a synthesis, where 2 elements or compounds come together to form one. So with this, you're looking for one product. Let's see if I have a highlighter somewhere. I'll just underline one product. That's a surefire way to know that that's a synthesis reaction. One reactant turns into more than one product. So if you have one reactant that's breaking down, we call that a decomposition. Single displacement. Single displacement is when you have an element, which is a single type of atom, and a compound. That element comes in and pushes out an element that's just like it. For example, zinc is a metal, so zinc will push out the metal here and replace it. Then the copper will be alone, and you'll have zinc chloride instead of copper chloride, and copper alone instead of zinc. This can also happen with negative ions. For example, here we have fluorine, which tends to make a -1 charge. So it will push out what's written second, the other anion, chlorine. And instead of having copper chloride, you have copper fluoride, and now chlorine is alone. And the double displacement is when the first 2 elements, or the cations, switch. So potassium is going to switch with silver, and silver is going to switch with potassium. So that's why that's a double displacement. Both of them switch. So instead of silver nitrate, now we have potassium nitrate. Instead of potassium chloride, we have silver chloride. Last but not least is you have some type of carbon and hydrogen compound reacting with oxygen. This is known as combustion. You might know the term combustion from the internal combustion engine, which uses these carbon-hydrogen compounds and oxygen to basically create energy. That produces always carbon dioxide and water. Use of this internal combustion engine has increased the amount of carbon dioxide production around the world since we use these to burn fuels. If you have a gas home, that's propane, right? If you use propane at home, if you've got a little lighter, that's butane. It's one of these carbon and hydrogen things. Your gas grill runs on propane again. Or if you have a natural gas home, that's methane. So all of those burn in the presence of oxygen and produce carbon dioxide and water. So let's look at it as a dance perspective. So synthesis, you come alone to a dance and you meet somebody else that comes along to a dance and you decide to dance together. Decomposition, you and your significant other go to the dance, something happens, and you break up. You and your couple go to the dance, or you go alone, and you have a switch of the partner there. Somebody says, oh, I'll cut in to this dance. Would you mind? Zinc comes in, Mr. Steal Your Girl or whatever, and replaces copper here. Now copper's sitting all alone. Double displacement, well, silver comes in to steal potassium's girl or whatnot, but instead of potassium sitting there on the bleachers alone at the dance, potassium says, I think I'll come over here and dance with nitrate. Combustion doesn't work very good with that. That would be as if, you know, the building that the dance is held in caught on fire. So yeah, one doesn't work. So if we take a look here, let's start right here. Here we have a compound. Here we have an element. Here we have a compound. Here we have an element. What type of reaction does that show? You can either type or you can unmute yourself. Give me one of those 5 choices. Is this a synthesis? Go ahead.
Is it halogens will replace halogens?
Yeah. So it was synthesis, decomposition. It would be a single replacement. The halogen here, oxygen is not a halogen, but basically it's going to be replaced by chlorine. So that would be a single replacement. How about this one? Compound element, compound element. So we have synthesis, decomposition, single replacement, double displacement or replacement. Actually, I'm going to change that to displacement because that's the terms I usually use. Or combustion. Nobody? Compound element, compound element. Which one fits that?
The single displacement.
Single displacement's correct. How about this one? Element, element, compound.
Is that Stereo Girl?
Louder?
Stereo Girl?
No.
Synthesis.
Yeah, nobody's being stolen here. These two are just meeting up to combine to form one thing. Synthesis. Number 4.
Wouldn't that also be synthesis?
Yep. Number 5. There's only one that looks like that.
Double displacement.
Double displacement's correct. Compound, 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 compound. If you guys don't know the difference between a compound and an element at this point, keep in mind, this is one type of atom, that's an element. 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 S and Cl, that's 2 different types of atoms, right? This is sulfur tetrachloride. That's a compound. This is just nitrogen. This is chromium 6 oxide. That's a compound. This is a compound. This is a compound. This is a compound. This is a compound. There's only one type that has compound, 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 compound. Right? All right. Number 6 is an outlier. It's actually 2 things. Can anybody tell me which 2 actually are occurring? This one's kind of amazing. Usually there's one or two people that can come up with what it should be.
I want to say it's double displacement, but I don't think that's right.
So a double displacement does occur first, and after which a second reaction occurs immediately after it. Any idea? Let's do a regular double displacement on it then. Here we have Ca, H2C2O6, and HCl. So what we would get would be Ca goes with Cl to make CaCl2. H goes with H2C2O6. Or what we would call C2H3O2, which is actually acetate. There's just two of them here. And then afterwards, this actually breaks down. Actually, it's C2H3O2. This breaks down into carbon dioxide and water. So after the double displacement occurs, we have a decomposition. Let's balance this one real quick. Get back to the balancing stuff. Here we have a Ca. Here we have one Ca. Here we have two Cs. Here we have one C. So in order to get that back, we need to put a 2 there. Here we have two H's. Here we have two H's. Oh, let's do the Cl's first. I almost missed those. Remember, we do hydrogen and oxygen last. Two Cl's. So we need two HCl's here. That's going to give us two H's plus two H's, which is four H's. So we need a 2 there. Here we have 6 oxygens. Here we have 2 oxygens plus 4 oxygens. What type of reaction would this one be? Number 7.
Double displacement.
Double displacement. This should be getting easier now, right? Number 8.
Wouldn't that also be double displacement?
Yep, very good. How about number 9?
Sin.
Yeah, it's single displacement. Good. Hydrogen comes in, pushes out iron. Iron's now all alone. Hydrogen's with oxygen. Let's go ahead and balance these two, and then I'll show you the assignment that's due after break. It would greatly help you review for the last 2 units that we've done for 9 weeks test on Friday. So I'm going to show it to you a little bit early, and then it actually reinforces all of this stuff. So 1 magnesium, 2 nitrates, 1 nitrate. We need a 2 in front of here. It gives us 2 Ks, 2 Ks, 1 S, 1 S. 2 H's, 2 H's. Oh, 3, this one's going to be kind of screwy. 2 Fe's, 2 Fe's. 3 O's. We need to put a 3 here. That's going to make us go back and fix our H's. So 3, 1, 2, 3. 3, 1, 2, 3. Remember, we don't put 1s because we wouldn't even write this here if there wasn't one of them. All right. The assignment that is due after break, it says Monday now, but I'm thinking about changing it to Tuesday, just to let you guys not worry about it over break, but then Monday come back. Or my major suggestion would be you get it done by the end of this week. That way you have everything ready for you when you get back. Take a look. We have iron 3 hydroxide. So this is a combination of last unit and this unit. So your goal is to write out Fe, hydroxide is OH. It has a -1 charge. Iron 3 is a +3 charge. So how do we make iron 3 hydroxide? It's not just FeOH. What do we need to put there? +3, -1.
It would be FeOH3.
You got it. But we don't just put the 3 there. We need to put what? Since it's-
Parentheses?
Yep, that's correct. Since that's a polyatomic ion, we need the parentheses around. So that is the one reactant. So over here, we have iron 3 oxide, FeO. O has a -2, iron has a +3. What's the least common multiple of 3 and 2?
6.
Good. 6 divided by 3 is 2 iron. 6 divided by 2 is 3 oxide. And water we know as dihydrogen monoxide, that is H2O. The next step you are to do with these is to balance them. So here you have 2 iron. So that means we need a 2 here. 2 Fe, and now we go to hydrogens. 2 times 3 is 6. So 2 times 3 is 6. 2 times 3 is 6 oxygens. Here we have 3 oxygens, and here we have 3 oxygens. So it's totally balanced. What type of reaction is this?
Decomposition.
Decomposition is correct. Decomposition is correct. That's it. That's what they want you to do for all 15 of these. Let's try one more, just to try to encourage some people to work on these before the 9 weeks test. So I'm going to try 4. Bromine is Br, plus hydrogen is H, yields hydrogen bromide. When I go to my periodic table, I look at hydrogen and I look at bromide, and I need to remember that they have these marks here, which means that they are never written alone. They are diatomic. So instead of just being Br, that will be Br2. Instead of just being H, that will be H2. Let's check to make sure that hydrogen and bromide's charges cancel out. Bromide usually makes a -1 charge. Hydrogen can make a +1 charge. So those do cancel out. What else do I need to do to it though? We need to balance the equation. How can we balance this? Some
You
people
can
don't
put
know.
a 2 in front of the HBr.
Put a 2 in front of the HBr. And what kind of equation is this?
Synthesis.
Synthesis is correct. So for tomorrow, what I'd like for you to do is you should have all of these evens balanced. I'd like for you to go through all the odds and balance them, and then tell all of the reaction types out to the side. That's the assignment for tomorrow. This backside is going to be for Tuesday when we get back. So if you want to work ahead, you're more than welcome to do that. If you have questions, stick around. Otherwise, use the rest of the period to get on that stuff.